Hi, I'm Aaron. My project is how salty does the sea have to be for an egg to float. The reason I chose this project was because I wondered if an egg would float in salt water, so I tried this experiment to find out. If an egg does float, would an egg float easier in salt water than in tap water? My hypothesis is I think by using more salt water that the egg will float to the top of the container. In my research, there were some words that I needed to understand. Density. Density is a measure of how much mass is contained in a given volume unit. Density equals mass over volume. Volume is a amount of space occupied by an object measured in 3 dimensions expressed in cubic units. Mass. Mass is a measure of how much matter is in an object. Buoyancy. Buoyancy is the ability for an object to float in a liquid. Chemical change. Chemical change is when it takes place on the molecular level. Physical change is concerned with energy and states of matter. What I will do with my investigation is first, I will get all my materials and set up my experiment. Next, I will do my rough draft using my materials, and I will start my video like what I'm doing now. I will then burn my video for my science fair presentation. And lastly, I will show everyone my video during the day of the KIC. Here are some resources and materials. I used Windows 2 Universe.com, Reference.com, and MathIsFun.com/dictionary are 3 internet resources I used. Science Explorer and Motion, Energy, and Forces book are 2 book resources I used to help me. To start my experiment, I'm going to need 5 eggs, and I'm going to allow them to warm to room temperature. Now I will make a stock solution, and I will get 1 quart of water, and then I will dump 1 cup of salt into the 1 quart of water. Now I will stir completely and make the salt. Now I will label cups 1 through 5. Cup 1, as shown, is stock solution. Cups 2, 3, and 4 will be dilutions of the stock solution in cup 1. And then cup 5 will be tap water. Now I will take 3/4 of stock solution and I will add it to cup 1. Now I will take 3/4 of a cup of tap water and I will add it to cups 2 through 5. Now I will take 3/4 of a cup of stock solution, then I will add it to cup 2. And now I'll mix. Then I will take 3/4 of a cup from cup 2, and then I will add it to cup 3. Then I will take 3/4 of a cup from cup 3, and then I will add it to cup 4. Now mix. parts from this, and I will dump this out to even up all of them. Okay, today what we did was we made a twofold serial dilution. So if cup 1 equals 100% of the stock solution, then cup 2 would equal 50% of the stock solution. So that means cup 3 would equal 25% of the stock solution, cup 4 would equal 12.5% of the stock solution, and then cup 5 would equal 0% of the stock solution, which is just plain tap water, so it would just be 0. Now we will test each egg in the water to see if they will float. In an effort to get constant measurements, we are going to use 1 egg and place it in each glass. Now we are going to see how many millimeters above the water line it is approximately. Looks at about 14 millimeters. In cup 2, we're going to see how many millimeters it is above this one. So this one looks at about 11 millimeters. Cup 3 in millimeters is, I'd say, at about 7 millimeters. Now we are going to do cup 4 in millimeters. And I would say at about 2 centimeters. Millimeters. Now we are going to do the millimeters in cup 5 of tap water. Looks about under it, so now we have to see how it is under. Looks at about 8 millimeters under sea level. So that would be. Now we are going to test the 5 cups using a hard-boiled egg to see if it makes any difference against a uncooked egg. Now we are going to test our hard-boiled egg in tap water. Looks to be about 8 millimeters. Millimeters per cup 4. Looks to be about -8. Now we'll just cup 3. This one's just loaded. Looks to be about 4 millimeters above water. Cup 2. Looks to be about, I'd say, 11 millimeters for cup 2. Now we'll test cup 1. And it looks to be about 14 millimeters. I learned that the hard-boiled egg had more density than the uncooked egg. So the hard-boiled egg would sink more than the uncooked egg. I also learned that it at least takes 12.5% of the stock solution for an uncooked egg to float, and that it takes at least 25% of the stock solution for a hard-boiled egg to float. Masses contained in a given unit. Here, weight equals mass over volume. Volume is I'm going to take one egg, and I'm going to take. Now I will get tap water, and I will add it to cups 2 through 5.
How much tap water? You didn't tell him. Start over.
Now I'll get 3/4 of tap water, and I'll add it to cups 2 through 5.
3/4 is not a measurement unless you tell him what you're using cups, right?
Yeah.
Your
I'm
issue.
going to get very mad. Instant measurements, we're going to use 1 egg to test in each glass in millimeters. To see
No.
how high.
Start over.
Oh,
You're rushing through it. You're trying to get your hand on your bottom.
Now in an effort, I don't even know what to say.
Now
we're going to test our 5 cups using a hard-boiled egg instead of using a uncooked egg.
You're gonna say it again.
Happy?
Say it again.
Now we are going to use a hard.
What is your
I'm going to
issue?
get very mad, and then I'm going to punch this in the face.
Go.
Now we are going to test. Now we're going to use the 5 cups and test the hard-boiled egg.
Now we are going to test.
Maybe you
The
should do
5
bloopers at the end.
I
That'll
need
be
a-
hilarious.
I need a cue card.
To see if it makes any difference against an uncooked egg.